Dividing rational expressions. In our book, this is problem type 1. The reason it's problem type 1 is because our rational expressions are made up of monomials. When we're talking about division, you need to multiply by the reciprocal if you're dividing fractions, or another way to remember it is copy, dot, flip. And that literally means I'm going to copy my first expression, or my first fraction. I'm going to change that to a dot, because a dot is multiplication. And then I'm going to flip my second fraction, or multiply by the reciprocal. Now I have two methods from this point. So I'm going to rewrite that so I can show both methods. In our first method, we're going to multiply straight across and then reduce. 15 times 2 is 30. X and then y times y is y squared. 5 times 4 is 20, and then x and y to the fourth. I need to reduce this now. 20 and 30 will both divide by 10. If I divide 30 by 10, I get 3, and 20 divided by 10 gives me a 2. My x's will actually cancel. And now I have 2 y's in the numerator and 4 y's in the denominator. 2 of those y's will cancel each other out, leaving me with 2 y's in the denominator. Now the other method we can use is cross cancellation. I can look at the terms that are across from each other. 2 and 4 will both divide by 2. So if I divide 2 by 2, I'm left with 1. And if I divide 4 by 2, I'm left with 2. I also have some y's. I have 1 y here and 4 y's here. This y will cancel with one of these y's, leaving me an exponent of 3. Looking at my other cross, 5 and 15 both divide by 5. I have 2 x's which will cancel. And then here we go. I have in my numerator and denominator, I still have y's. I have 1 y in the numerator and 3 y's in the denominator. One of these y's will cancel, leaving me with 2 in my denominator. Now for clarity, I'm going to rewrite that, and I have 1 over 1 times 3 over 2y squared, which just gives me 3 over 2y squared. For our next example, again, we're talking about division, so we need to multiply by the reciprocal. So I'm going to copy the first term, dot, and flip. And I'm going to write this twice so that I can show both methods. Okay, in our first method, we multiply straight across. So 12 times 3 is 36. I have a b to the fifth, and then x times x gives me x squared. Across the bottom, 4, I have a b to the third, and an x to the fourth. Now if I reduce these, 36 divides by 4 9 times. I have 5 b's in my numerator and 3 b's in my denominator. 3 of these b's will cancel, which leaves me with 2 b's in my numerator. And I have 2 x's in my numerator and 4 x's in my denominator. 2 of those will cancel, leaving me 2 x's in the denominator. If I want to cross cancel, 4 will go into 12 3 times and into itself once. I have 1 b in my numerator and 3 b's in this denominator. One of those b's will cancel, leaving me an exponent of 2. Oh, darn. I made a very big typo, or a righto. That should have been a 5. So, this changes things up a bit. Apologize for that. I have 5 b's in this numerator and 3 b's in the denominator. 3 of these b's will cancel, leaving me 2 b's in my numerator. That's why we always need to check to make sure we recopy things correctly. Looking at my x's, I have 4 x's in this denominator, 1 x in this numerator. One of these x's will cancel, leaving me 3 in the denominator. Now for clarity, I'm just going to rewrite this. I have 3b squared x over x to the third times 3 over 1. And this is why I like to rewrite it. It was a little messy over here, but here I can see I still have some x's that I need to deal with. This x will cancel, leaving me 2 in my denominator. So now when I multiply that, I'm going to get 9b squared over x squared. And that is how we multiply or divide rational expressions.